So we do have these rules of logarithms, and we can use that to change expressions into forms that we could deal with. This is going to be really helpful when we go to actually solve logarithmic and exponential equations in section 3.4. But for now, let's just go ahead and look at some more complicated problems. So if we think about these rules, what we're really doing is taking one log and breaking it into many. So that's one way of thinking about it, is in terms of an expanded form of a logarithm. Of course, we want to go ahead and expand these to the as best as we can. So let's go ahead and just look at a few examples to see how things feel. Well, in the first example, let's focus on this one. We have log, and then this whole expression is the input to the logarithm. So there's a couple things I noticed. I'm going to go ahead and first deal with like the product rule and the quotient rule. And then I'll go ahead and deal with the power rule. So across the top, we have an x squared as our first expression, and then we have this x minus 1 cubed as our second expression. And that's all divided by the 2x plus 1 to the fourth. So let's go ahead and just use the product rule and the quotient rule. So we have the multiplication on the top. So anything on the top is going to be a positive logarithm. So we have log of x squared. And then we're going to add to that, well, the second expression, which is log of x minus 1 cubed. And then the last expression is in the denominator, so it's going to be a negative. Then we have log of 2x plus 1 to the fourth. And now we can go ahead and apply the power rule last. Of course, there are exceptions, as you maybe think is the square root may be over the whole expression, as we have a later example, and we would have to apply the power rule first, kind of working outside in. But the 2 is on the x, so that could come in front. So this becomes 2 log of x. The 3 is on the parentheses x minus 1, so this becomes plus 3 log of x minus 1. And then the same thing with the 4, it comes down in front, 4 times log of 2x plus 1. And you may be asking yourself, do I need these parentheses? And in this case, whenever you have an expression that has more than one term, you do need the parentheses. Because notice in this, if we don't have it, it looks like the 2x is the only input to the logarithm, when in reality, the whole 2x plus 1 is what we plug in, or what we evaluate the logarithm with. And if I'm looking through this note, again, I'm done because there's no, don't distribute the logarithm, because you may be tempted to do that, but definitely don't do that. All right, let's go ahead and look at this next example. In this next example, you can see that we actually have the square root all the way out, and everything's inside the square root. So the first step here was to deal with that square root. And again, remember that the square root, here we have log base c. The c doesn't matter, but notice I'm keeping the same log as I expand. We have x cubed times x, or now y squared, z to the fifth. And this is all in the square root. So the 1/2 power is going to be affecting all of that. So here you now see that 1/2 needs to come out first. So we have 1/2 log of c of x cubed y squared z to the fifth. Now applying the power rule, we would have 1/2, and we have log c of x cubed plus log, so continuing to apply the product rule, we have log base c of y squared. And then we have plus log base c of z to the fifth. If you wrote it like this, you're not technically correct, because remember, this 1/5 needs to be affecting this whole expression right here. Excuse me, this 1/2 needs to be affecting this whole expression right here. And now just applying the power rule with the exponents on each of the individual variables, we have 1/2, and then you would have 3 log base c of x plus 2 log base c of y plus 5 log base c of z. You really think about it, you could distribute the 1/2 here if you want. Again, that really all depends on your purpose. For right now, we're just expanding, and this really does look expanded. So we have two more examples down below, very similar to the ones we've encountered above. I'd encourage you to take a moment and see if you can simplify these before I do so. All right, now let's look at these worked out. So in the case of C, we have a quotient. The expression on top is 2x minus 1. So when we expand it, that is going to be the 2x minus 1. The ln is going to be a positive, of course, because it's positive, we don't need it. And the x plus 4 is in the denominator, so this expands to ln, or minus ln of x plus 4. Again, do not distribute, as we have no addition or in turn no subtraction property for logarithms. And in this last case, again, this first transformation would be just to take this expression right here, and you would have 4xy over z to the 1/2, rewriting the square root as an exponent, so we can use the power rule to put the 1/2 in front of this log. Then we have 4xy over z. And then the 1/2, writing in parentheses because I'm breaking this up into more logs, we'll have log base 10, because nothing's written, of 4, plus log of x, plus log of y. Again, those are all positive because they were in the numerator, but that then leaves us with minus log of z.